A few weeks ago, I was doing some research on this video on why 90s programmers were so legendary, and it kind of blew my mind. There were so many programmers outside the 90s that I couldn't even talk about, like say Notch. Sure, he wasn't a great developer, anyone that's played the beta edition of Minecraft would know, but he built a billion-dollar game in freaking Java. Let that sink in. A programmer trying to build a game in 2025 would lose their mind just picking through the Unity tutorials. I mean, there's actually a joke in the game dev community. Minecraft would have probably never happened if Notch started by asking in the forums if he should use Java or not. Real. I also didn't even get to mention Margaret Hamilton. She wrote the moon landing code. Code so good, people still think it's fake. I had a peep at the code since it's openly available, and I couldn't understand a freaking thing, because it's written in assembly. My matcha-drinking, wallet-chain, performative male brain couldn't comprehend it. Actual code in assembly. And then there's so many other legendary computer scientists I couldn't even mention. So that got me wondering, if I took all these legendary programmers and respawned them in 2025 with a MacBook and a matcha, would they still be as legendary? Are they built different? Are we as a generation just fundamentally chopped? Unfortunately, we'll never know. But what I can do is go back in time and try and understand some of the principles that these programmers have used and how we can learn from them today. So principle number 1, never null again. Let me introduce you to my boy, Tony Hoare, a legendary British computer scientist. You ever seen this in CS class? Yeah, he made it. It's literally named after him. You ever heard of a little thing called quicksort? He made that too. Calling him a legend in computer science would genuinely be an understatement. He's invented so many things, but one of his inventions he's had to come out and apologize for, the keyword null. Now initially, Tony made null as a clean way to point to nowhere. You see, before null was invented, developers just used impossible values, like void, an empty array, an empty string, -1. You can imagine how chaotic this got because every developer had their own version of null. But at least programmers back then had a little bit of shame. They'd avoid using these words, or at least deeply rethink their code before they had to use one. The null keyword gave all of us an easy out when we can't think of anything. And thanks to that, you can almost have a Marvel cinematic universe of invalid states in your code now. Now the takeaway isn't to avoid null entirely, that would be silly. But you should really rethink your code instead of just throwing it around. Look at this Python snippet that sends a welcome email. Now right off the bat, user.getEmail could return literally anything. None, an empty string. It could return anything except that Amazon package that's been sitting in your bedroom for 5 months. This means whenever you're trying to access the email property of a user, you need to build out a guardrail. That too every single time you use it. Otherwise, your code can crash seemingly at random. Now, a better way to approach this would be to create an email type. Instead of raw dogging strings, we can wrap the logic into a class which makes it standardize. Whether you use it here or anywhere else, you can expect the email type to be consistent. If you ever catch yourself hitting null pointer exceptions too much, rather than going through the try-catch spiral of doom, think about redesigning what you've written. And while you're deep in thought, you should also be thinking about the second principle, deploying data structures. This is Rob Pike, a programmer from the land of maple syrup, who worked on Unix when he worked at Bell Labs. And yes, that Unix. He's also known for designing this little creature over here. Rob has this list of 5 rules for programming, which I could easily make an entire video on. But the one I want to focus on is this last one. If you choose the right data structures, the algorithms will follow. That made 0 sense to me, until I saw this code snippet. You have a list of users, each with a name and a role, and you want to print out which user has the admin role. We could just look through all the values and put it into an array. There are a bunch of problems with this approach, but I'll stick to the most basic one. What if we wanted to track a new role? Our code falls apart instantly. Now you might be thinking, what kind of crazy odd data structure are you thinking of implementing? Literally enums. We can just define different roles as an enum. This immediately narrows down the scope of our work. From there, we can just define a class. Now, it's impossible for either the role or the user to be invalid. And although the final output is the same, in the second version I can add new stuff without breaking my brain. Data structures aren't just for elite code. They're an amazing tool to write robust and scalable code. So as soon as your code starts feeling as brittle as a papadum, think about how you can implement data structures. And as I just showed you, they don't have to be super complicated. That leads us to the final principle. Write code for humans. In this age of maximal efficiency, hyper productivity, we can be tempted to optimize everything. Fast, precise, tricky lines of code. But ultimately, whether it was 50 years ago or now, code is written for humans. And although a single tricky line of code looks really cool when you're writing it out, it's an absolute pain when you have to revisit it literally 2 days later. Or even worse, when you're looking at someone's tricky code from 20 years ago. These 2 code snippets functionally do the same thing. It's just one of them makes it very clear what it's doing, and the other one makes anyone who's ever interacted with your code hate you at first glance. If you're ever finding yourself squinting to understand a line of code, just rewrite it. More lines of code isn't necessarily bad. More lines of code is actually great, because code is meant to be read and used, not just admired. Ultimately, all of these principles just boil down to one core idea. Keep things simple, because programming is really freaking hard, and it gets out of hand really fast. Whether you're writing code for the moon, coding for Minecraft, coding for Zigachu, the only variable you can really control is you. And thankfully, that's the best variable of them all. One thing I can't control, however, is how much I'm using Whisperflow, the sponsor of today's video. For someone that lives behind a computer desk, damn, I suck at typing and spelling. Like, my biggest op is any double-letter word, like accommodate or dumbbell. Now, you might be thinking, bruh, autocorrect and spell check have been around for ages, but I don't want NeoVim corrected to neoclassical like 100 times a day. And I swear, spell check does not work. Literally, as I'm writing the script, the word accommodate is misspelled. Thankfully, thanks to Flow, I've forgotten to worry about spelling. I can just send out a message saying, hey guys, super happy to accommodate another SSO release this week. I'll write up a postmortem on why this happened. Ah, peace at last. But no, it's not peace at last because I actually have to write up that postmortem report. Thankfully, to get started, all I have to say is postmortem template. You see, Flow has this thing called snippets. They're like voice shortcuts. You can define them in the app like I did here with the postmortem template, and then say the shortcut term whenever you need it. Now, you may have noticed, I was using Flow on Slack and Notion. That's because Flow literally works anywhere. A website, an app, your search bar, all you need is a text box. Get started with Whisperflow today for free on Mac, Windows, and iPhone. Check out the link in the description and pinned comment. The link also gives you an extra month of Flow Pro for free. Thank you to Whisperflow for sponsoring this video. And thank you for your time. I am Big Box.